You have seen branch and bound technique. Already we have discussed one problem under branch and bound technique, that is assignment problem. So we have another problem called as the Snapshot problem. Already we have discussed Knapsack problem in our dynamic programming and other technique also. Now here also we have the same problem, but we are going to solve it by using the branch and bound. So it is a very simple problem, and many of the times you can expect this particular problem in your question paper. So what do you mean by Snapshot problem? You already know that there are n items with weight W1 to Wn and values or profit V1 to Vn. So the total capacity of the knapsack is given for us. So what is our problem? We have to maximize the total profit. Now such that, so when you find the items, when you pick the items, n items, you have to pick in such a way that the maximum capacity of the knapsack, it should not be, that is weight of these items should not be greater than W. So it is a maximization problem. Since it is a maximization problem in branch and bound technique, so we are going to find the upper bound. So initially, now how we are going to find the upper bound? So to find the upper bound here for Snapshot problem, you are going to use this particular formula. So upper bound is equal to V. So V is the profit. So this is the profit for each item what is given, plus capital W, that is the weight of the maximum capacity of the knapsack, minus small w, weight of individual item, whichever item you are going to select. So if you select first item, now that item has got some weight small w and it has got some profit small v. So multiplied with profit to weight ratio, so that is V of I plus 1. If you are selecting ith item, so this profit to weight ratio should be of second item. If you I is equal to 1, if you are having the first item, if I is 1, so you have to find the profit to weight ratio of I plus 1. So here you have to remember this. You generally will get confused here. So it is V of I plus 1 divided by W of I plus 1. If you are selecting first item, so then here it is V of 1 plus 1 2. It will be the profit of second item divided by weight of second item. So this is the one important thing which you have to remember. So now let us try to solve the problem, how we are going to solve and how we try to find the upper bound and draw the state space search. So now the problem is given for us. So we have to solve this knapsack problem. The maximum capacity W is given is 10 for us, and there are 4 items and the weight of each item, so is taken. The item 1 weight is 4 kg, so item 2 7, item 3 5, 4 is 3 kg, and profit is given for all these 3 items. So for first item profit is 40, so we are writing it in a table here. So 40, for second item profit is 42, and third item profit is 25, and fourth item profit is 12. So in the next column we are going to find profit to weight ratio, right? So what is this? So profit to weight ratio means for first item, so VI divided by WI, because in our formula we are having, so we have that we have to calculate the profit to weight ratio. How do you find? See here, profit of first item here 40 divided by the weight 4, so you will get 10. 40 divided by 4 is 10, so VI divided by WI. Similarly 42 divided by 7 is 6, 25 by 5 is 5, 12 by 3 is 4. So this is the profit to weight ratio. So now we are going to start the state space search with profit is 0. That means you are not selecting any item. Initially you have to find the lower bound. First lower bound you have to find when you have not selected any item. So what will be the weight now? Since you have not selected any item, weight will be 0 and your profit also will be 0. So now you find the upper bound by using the formula. So upper bound is equal to V. So what is the profit now? Since you have not selected any item, profit will be 0 plus capital W. What is the maximum capacity of this knapsack is 10 minus small w. What is the weight here? Since you have not selected any item, so weight is 0 minus 0 multiplied by VI plus 1. Now since you have not selected any item, so what will be the value of I now? So here I will be equal to 0 because you have not selected any item. So now V of I is 0 now. 0 plus 1 is 1. Right? V of 1 divided by W of I is 0 initially. So 0 plus 1 is 1. So V of first item. So what is the profit of first item from this table? Profit of first item is 40 divided by weight of first item is 4. 40 by 4, that is nothing but 10 here, right? Either you can directly use 10 here or 40 divided by 4. So when you calculate here, you are going to get upper bound as 100. So your upper bound is 100. So initially your upper bound is 100. So now we will start creating the state space search tree, and we'll try to solve this particular problem step by step. So the first thing what we are going to do is you are going to find the upper bound. So when you are not selected any item, so since you are not selected any item, you are going to find the upper bound, right? So let us see how we are going to solve this particular problem. Okay, so I think it's taking bit time for that to load. So once it is loaded, we will yes, so this is our problem. Okay, so now what we have done initially, so initially W equal to 0, right? So we have not selected any item, weight is 0, profit also is 0. What is the upper bound we calculated? Now we got upper bound as 100. Now from here, now we start selecting one by one item. Now with 1, right? So with 1. So if you select first item, so what is the weight of the first item? Weight of first item from table you can check. Weight of first item is 4 kg and profit is 40. So now, so I is equal to what now? I is equal to 1. That means you are selecting first item, so I is 1. So weight of the first item is 4 kg and the profit V is equal to 40. So now you find the upper bound by using the formula. Now upper bound is equal to V. So V is how much here? 40 plus capital W. Capacity of the knapsack, maximum capacity of this knapsack is how much? 10 minus weight of this first item is 4 kg. 10 minus 4 into profit to weight ratio. Now here if you look into the formula was V of I plus 1. Now what is I here? I is 1. So that means this becomes V2 divided by W2. So now in our table, if you look what is the profit for second item profit is 42 and weight of the second item is 7 kg. So 42 by 7, right? So you just check it here. So you will get confused here only. So the formula says V of I plus 1 divided by W of I plus 1. I is 1 here. So I plus 1 is 1 plus 1 2. So V of 2 divided by W of 2. You get how much upper bound if you calculate? You get upper bound as 76. Now here in this column you are going to write upper bound 76 and you draw this diagram or state space tree. So now if you select the first item, this is how much you are going to. Now if you don't select the first item without 1, so here 1 means what? First item, right? Now without 1, so if you don't select the first item, now what will be? Now I is 1, that means you are interested in first item. You have in front of you, you are checking with the first item, but whether you are selecting or not, it is left to you. So since I is equal to 1, you are just inspecting first item. Now what is the weight you will be having now? So weight will be 0. Previous weight. Previously what was the weight? When you are not selected any item, weight will be 0 and profit also is 0. Now you find the upper bound. Now upper bound equal to 0 plus 10 minus 0 into V2 by W2. That means into 42 by 7. So your upper bound will be 60. So now you will write here weight is 0, profit is 0, upper bound is 60. So now if you select the first item, you get upper bound 76. If you don't select first item, you will get upper bound 60. Now we have to see, since it is an upper bound, we have to maximize the profit, which is greater value between 76 and 60, 76. So we will go in this direction. So we will go in this particular direction. So we are not going in this, we are not going to consider this one. So we are going in this particular direction. Okay. So now we'll start looking into the second item with 2. Second item we will consider. Now what is the weight of our second item? Right, so weight of the second item is 7 kg. Now total weight, so previously already here you have selected first item weight was 4 kg plus weight of second item is 7 kg. Now totally how much weight you are going to get? 4 plus 7, 11 kg. But what is the capacity of our knapsack? Maximum capacity is only 10 kg. If you select second item also, since already you have selected first item whose weight is 4 kg, so still how much is left in our knapsack? Only 6 kg is left because you selected first item. Now if you select the second item also whose weight is 7 kg, now when you add this 7 kg to 4 kg, it becomes 11 kg, which is greater than capacity of our knapsack. So we say that this solution is not feasible. So we cannot go in this direction. That means you cannot select the second item. Now we will come here. Now without 2, right? If you are not selecting the second item, right? So now we will come to this. Now we can call this as node 4 here. So first node, second node, this is first node, root node this is first node, second node, third node and fourth node. So now without second item. So for fourth node, what is the calculation? Now I is equal to how much now? 2, because you are scanning second item. So I is 2. Now what is the weight? W equal to. Now when you are at this node, so what was the weight previously? Previous weight was how much? 4 kg and profit was 40. So we will write weight equal to 4, V equal to 40. Calculate the upper bound. Now upper bound equal to V, that is 40, plus capacity of knapsack 10 minus weight of this item 4 multiplied with, now what is I value? I is 2, so multiplied with plus 1, you have to add plus 1 to this, V3 by W3. That means profit of third item divided by weight of third item. Profit of third item given in our problem is 25, weight of third item is 5 kg. So when you substitute and calculate here, you will get upper bound as 70. So we will write down here upper bound as 70. Right. So next we will, so now 2 items are completed. Now we will go to third item. We will scan the third item with 3. Now if you select the third item, now what was the weight previously? You are having 4 kg. What is weight of third item? 5 kg. So when you add 4 plus 5, what is the weight you are going to get? 9. What is the capacity of this knapsack? 10 kg. That means 9, you can take this because 9 is less than 10. So now when you select this item, that is third item, when you select, now you want to calculate what is your upper bound. So now what will be the profit you are going to get? Already previously what was the profit? 40 plus profit of this third item is 25. So 40 plus 25, you get V as 65. Now you can see here the calculations what we have done for node 5. Now I is 3, third item. Now what is the total weight you are going to get? 4 plus 5 equal to 9. So we are considering here total weight as 9. What is the profit? Previous profit was 40. Profit of third item is 25. So total you will get 65. Now you calculate the upper bound by using same formula. So upper bound equal to how much? 65 plus 10 minus 9 into, see I is 3. So you should see, we should multiply it with V4 by W4. V4 by W4. So weight of fourth item, profit of fourth item is 12. Weight of fourth item is 3. You substitute. So you will get the upper bound as 69. So if you select the third item, you are going to get a upper bound as 69 with a profit of 65 rupees or 65 units. Okay. Now if you don't select the third item, now what will happen? So that is node 6. So now you can come below and you can check what is the calculations you are going to do for node 6. Right. Now if you don't select the third item, what will be your weight? So previous weight. So previous weight how much? Previous weight was 4 kg and profit was 40. Right. So now if you don't select, you will be having same thing. So I is 3 now. Right. Third item you are scanning. What will be the weight? Previous weight is 4 kg and previous profit is 40. So you calculate the upper bound now. Upper bound is equal to 40 plus 10 minus 4 into V4 by W4, that is 12 by 3. So you will get upper bound as 64. Now, if you select the third item, your upper bound is 69. If you don't select the third item, your upper bound is 64. Now, which is better for us? 69 is better for us. So, we go in this direction. So, that means you are going to select the third item, right? So, now which all the items you have selected? So, you should note it down which all the items you have selected. So, you have selected item 1, then you have selected item 3, right? So, you have selected item 1 and you have selected item 3. Now, you are left with the last item. So, if you select the fourth item, now right now what is the total weight you are having? 9. That means only 1 kg is left. Maximum capacity of Snapsack is 10 kg. Now the weight of the fourth item is 3 kg. So 9 plus 3 is 12, which is greater than 10. So this is not feasible. So you cannot go in this direction. Now if you don't select the fourth item, if you are not going to select, this is the last item you are having. So if you don't select the fourth item, what is the weight you are having? 9. Total previous weight 9 plus profit is 65. So now your upper bound value. So now you can calculate the upper bound value. So now for this particular node 8, so now there is no additional, what you can say, no additional condition, because if you calculate the upper bound here, so now you are going to use V5, right? So now V5 is not there for us since only 4 item is there. So here V of I plus 1 divided by W of I plus 1 you are going to do, but you don't have that. So since it is the last item, so you need not calculate. So directly we can say that. So you can stop and we can tell that this is the solution. So now you can note that the items what you have selected. So your upper bound value here for this will be same as your profit. Now what is the profit you have got? So the same will be your upper bound value. So and you can stop the problem. So now what all the items you have selected? So if you look into this particular the state space graph what you have drawn, now clearly you can write the solution, that is which all the items you have selected and what is the maximum profit. So now you started from the root node here, you selected first item, right? The out of 4 items, which are the items you are going to select? You are selecting first item, you are not selecting second item, so you come in this direction, then you come in this direction, that means you are selecting third item, right? And here you are not selecting fourth item. So what are the 2 items you have selected? You are selecting the first item and you are selecting the third item. If you select these 2 items 1 and 3, so item 1 you are going to select and item 3 you are going to select. And what is the total profit you are going to get? So the total profit is equal to 65. So that is your solution. So you have to write down the items what you have selected and what is the total profit. So this is how you are going to solve a Snapsack problem by using branch and bound technique, right? So you just practice this particular problem. It's a very simple problem. Now you can solve this in a more faster manner than your dynamic programming. Clear? So practice this particular problem carefully.